Welcome to Com Planner Studies, your favorite YouTube channel that gives you the good explanations you deserve, the simple, easy to use, easy to understand explanations about things related to science and technology. So, in this video, we'll be covering digital logic design, and we are going to be taking our first lesson. That's lesson one, how to convert from base 2, 8, and 16 to base 10. Let's dive right into it. So first of all, we have to establish what number-based system is. A number-based system is just a way of a system in which we can count, a system of counting, a system of expressing numbers. So we have four major number-based systems in digital logic design. So the first one is base 10. So in base 10, you have only 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So by digits, we mean that you only have 10 numbers. You have just 10, and you use these 10 numbers to express numbers in base 10. So it is the number base used in natural counting. It is the number base used in natural counting. We use it every day to count. Let's say you want to count the number of cars in the garage or something like that. Counting, we use base 10 in our everyday lives. So we have base 2, and in base 2 we just have two digits, only two, and they are just 0 and 1. So in base 2 we should expect zeros and ones. We'll look deeper into base 2. We also have base 8. The digits used in base 8 are 0, 1, 2, 3, 4, 5, 6, and 7. So you tend to notice a pattern. You notice a pattern that the highest digits available in any number base is just that number base minus 1. What I mean is this: in base 10, the highest digit is 9. So 10 minus 1 is 9. So base 10 goes from 0 to 9. For base 2, the highest digit will be 1, because 2 minus 1 is 1. So you only have two digits there, 0 and 1. Then for base 8, the highest digit is going to be 8 minus 1. So that will be 7. So you just have from 0 to 7. And then for base 16, the digits used are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, you'd expect base 16 to go up until 15. But the thing is, when we talk about a digit, we are talking about a single figure. It should be just a single thing, not two things, because 11 is one and another one joined together. So we're looking for a digit. So to fix this problem, we use letters. So A represents 10, B represents 11, C represents 12, D represents 13, E 14, and F 15. You notice again that the highest digit available is 15. That's 16 minus 1, 15. So base 16 has 0 to 15, but then 10 to 15 are represented by letters of the alphabet: A, B, C, D, E, and F. So that's very important as well. So let's dive right into solving examples. We want to convert from base 2, 8, and 16 to base 10. So in our first example, we are asked to convert 110011 in base 2. So this is in base 2 to a number in base 10. So we need to convert this number in base 2 to a number in base 10. How do we do it? The first step you're going to take is that you are going to number each digit. So you're numbering it like this: 0, 1, 2, 3, 4, and 5. So you start numbering from your right to your left. So you move from the right to the left. right to left. So you number it like that: 0, 1, 2, 3, 4, 5. Now we are going to convert this number in base 2 to a number in base 10 by following this procedure. So here's how it's going to go. The digit here is 1, right? So I'm going to write 1 multiplied by 2, because this is the base. This will be constant. This figure here is going to be constant because it's the base. So take note of this. It's going to be constant throughout. So 1 times 2 to the power of 0 to the power of 0. So 1 times 2 to the power of 0. For this one, we have 1 times 2 to the power of 1. So the power here is just your number that you wrote, the number you wrote on top of each digit. That will be the power of 2. So using that, here we have 0 times 2 to the power of 2. You can have 0 times 2 to the power of 3. 0 times 2 to the power of 3. Then we have 1 times 2 to the power of 4. Because 4 is the next one. And finally we have 1 times 2 to the power of 5. So you notice that the powers of 2 are just the numbers, your numbering. The numbers you gave each digit starting from the right going to your left. So the next step is to evaluate each of these expressions. So what is 1 times 2 to the power 0? So you've got to take note that 2 to the power 0 is always 1. It's very, very important to note that when you've got 2 to the power 0, when you've got 2 to the power 0, you get 1. Yeah, because any number to the power of 0 is 1. So any number at all, even if it's a million, even if that number was very, very large, once it is to the power of 0, it's going to be 1. So to the power of 0, it's going to be 1. Any number to the power of 0 is 1. So that's very important to take note of. So this gives us 1 times 1 is 1. 1 times 2 to the power 1, that's 1 times 2, which is 2. 1 times 0 times 2 to the power 2 is 0 times 4, which is 0. Well, any number multiplied by 0 is always 0. So we don't really need to evaluate 2 to the power of 3 because we know that it's going to be multiplied by 0. And anything you multiply by 0 gives you 0. So you just have a 0 there. And here we have 1 times 2 to the power 4. 2 to the power 4 is 16. So we give me 16. And here 1 times 2 to the power 5. 2 to the power 5 is 32. So we got 1 times 32 giving you 32. Then the last step, we're going to want to add everything you have here. So 1 plus 2 is 3, right? So we've got 3. So we are summing up everything here. Sum up plus. We are summing up everything. We're going to add everything together to get our final answer as 3 plus, this is 3, then plus 16, 19, plus 32. So I have 19 plus 32, right? That will give me 11, 551. 51 as my final answer. And yeah, 51. So 51 in base 10. So that's my answer. So I can now write that 110011 in base 2 is equal to 51 in base 10. So let's move on to the next example. What we have is convert 101101.101 in base 2 to a number in base 10. So I'm just going to write that down. 101.101 in base 2. So we seek to convert this number to a number in base 10. So here's how it's going to go. We're going to number as usual. Now take note, there's decimal points here. So your numbering starts from the number to the left of the decimal point, to the left of the decimal point. That's here, the number that comes before the decimal point. So it's 0 here. This is where your 0 is. Now remember, we said that you number from the right to the left, right? So 0, 1, 2, 3, 4, and 5. So I started from 1 here, and I've numbered all the way to 5. Now, what about the decimal places? So here's going to take a -1, -2, and a -3. So this is 1 taking on -1, 0 takes on -2, and 1 takes -3. So that's how it's numbered. That's how you number it. You number it using that method. So now that we know we've numbered, you can now evaluate the result. So we have 1 times 2 to the power 5, right? 1 times 2 to the power 5 plus 0 plus 0. Well, anywhere you see 0, you don't really need to evaluate it because 0 times anything is always 0. So, but for the sake of understanding, let's put it there. 0 times 1 plus 0 times 2 to the power 4 plus 1 times 2 to the power 3. Okay, we have plus 1 times 2 to the power 2 plus 0 times 2 to the power 1. Okay, we have plus 1 times 2 to the power 0 plus 1 times 2 to the power -1 plus 1 times 2 to the power -1, there's a -1 there, plus 0 times 2 to the power -2 plus 1 times 2 to the power -3 plus 0 times 2 to the power -2 plus 1 times 2 to the power -3. So that's how we're going to do it. So let's evaluate what we have here. So here we just have 1 times 32, right? Plus, when you have this, when you come across this, where you got 0, this everything here is just 0, right? Everything here just 0. 0 times anything is 0. So remember that's 0 plus this is 1 times 8, right? This part here, 1 times 8, 2 to the power 3 is 8, plus 1 times 2 to the power 2 is 4, plus again you come across 0, you come across 0, this is 0 now, 0 times anything is 0, so plus 0, then here you come across this, a 1, this is 1. This is also 1 times 1, right? 2 to the power 0 is 1. So plus 1 times 1 plus 1 times. Okay, so we have this part here where we have 2 to the power -1. How do we simplify it? 2 to the power -1 is actually, so you've got 2 to the power -1, right? And you want to simplify. This is 1 over 2 to the power 1. Which is 1 over 2. So the essence of this is that whenever you have any number to the power of -1, it's just equal to 1 over 2 or over the number raised to the power 1. So in this case we have 1 over 9. But in general, if we have a to the power minus b, if we've got a to the power minus b, to simplify this, we'll say 1 over a to the power b. A to the power minus b is equal to 1 over a to the power b. So this is a very important formula that we're going to use. So 1 over the number to the power without the minus sign, a to the power b. So using that logic, we can simplify 2 to the power minus 1 as 1 over 2 to the power 1, which is 1 over 2, plus 0 times 1 over 2 to power 2. Because we have this here, 2 to power minus 2 is 1 over 2 to power 2, plus we've got 1 times 2 to power 1 times 1 over 2 to power 3, 2 to power 3, 1 over 2 to power 3. So let's see what we've got at the end. Let me see, what do we have? We've got 1 times 32 here, which is 32. 1 times 32 is 32. Plus, well, we can omit the 0. 32 plus 0 is 32. 1 times 8, 8. 1 times 4, that's 4. We come across a 0, we can omit the 0, it's not important. And then we come across 1 times 1, that's 1. We come across this 1 times 1 over 2 to power 1, that's 1 over 2, right? 1 times 1 over 2 to the power 1 is 2, so this is 1 over 2. This will 0 out. This becomes 0. And we have 0, right? So it's not really necessary to write it 0. We can write it as 0 plus 1 times is 1 over 8. 1 times 1 over 2 to the power 3. 2 to the power 3 is 8, so it is 1 over 8. And 1 times 1 over 8 is 1 over 8. So we want to simplify this. So this is what we're going to do. We're going to add the numbers together. Add all numbers together and add all the fractions together. So adding all these numbers, we have, if I add all those numbers, we have 32 plus 8 plus 4 plus 1. That gives me 45. So 45 it is. 45 plus, adding these together, 1 over 8, or 1 over 2 plus 1 over 8. If you want to add that, then you get, well, you can just use a calculator, or you can just simplify that using normal addition. LCM here is 8, so 8 divided by 2 is 4. It's 4. 4 times 1 is 4, plus 8 divided by 8 is 1. 1 times 1 is 1. So essentially we have 45 plus 5 over 8. And well, you can use a calculator for this. You can use a calculator. 45 plus 5 over 8, that gives 45.625. So the answer becomes 45.625 in base 10. 45.625 in base 10. And yeah, so that's essentially it. So now let's move over to our next example. We want to convert 236 in base 8 to a number in base 10. So in this time around, we're working with base 8, right? So 236 in base 8. In base 8. Converting this to base 10, we're going to use the same method we used for base 2, whereby we number each digit, right, in this manner, 0, 1, 2. So what's it going to be? 2, the digits here, 2 times 8, base 8 now, not base 2, base 8, to the power of 2, to the power of 2 plus 3, the next digit here is 3, 3 times 8 to the power of 1, plus 6 times 8 to the power of 0, 6 times 8 to the power of 0. So we are ready to evaluate this. Once we do this, we can now finally get the answer. So we have 2 times 8 to the power 2 is 64 plus 3 times 8 to the power 1 is 8, right? And we have plus 6 times 8 to the power 0. Again, we face this. 8 to the power 0 is 1. It's 1. So anything to the power of 0 is always 1. So we have 6 times 1, and we are solving that. This gives us 2 times 64, which is 128, plus 3 times 8, which is 24, plus 6. So this gives us 128 plus 24 plus 6, 158 in base 10. 158 in base 10. So now we know this, let's move over to example 4. Okay, so in example 4, we're asked to convert 413.75 base 8 to a number in base 10. So basically, we're just using the same process as in base 2, but just that the 2 turns to 8. 2 will change to 8. That's the difference between what we're doing. So converting this to base 8 is very easy. As usual, we start numbering from the number before the decimal point. So 0, the 3 here takes on 0, the 1 here takes 1, the 4 takes 2, the 7 takes minus 1, the 5 takes minus 2. So let's solve it. 4 times, remember the base we're using 8, very important, base 8. 4 times 8 to power, it tells you the power here, 2 to power 2, plus 1 times 8 to power 1, plus 3 times 8 to power 0, plus 7, the next digit 7, the next digit 7, times 8 to power minus 1, because there's a minus 1 here, plus 5 times 8 to power minus 2. So simplifying, we have 4 times 64 plus 1 times 8 to power 1. 1 times 8 to power 1, that's 1 times 8, because 8 to power 1 is 8, plus, as usual, this part here is 1, so 3 times 1, 8 to power 0 is 1. Then we have plus 7 times, we have to take note of this, this is 1 over 8 to power 1, as we have already established, 1 over 8 to power 1, plus 5 times 1 over 8 to power 2. So we solve 4 times 64 is 256 plus 8 plus 3 plus, now this makes it 7 times 1 over 8 plus 7 times 1 over 8 plus 5 times 1 over 64. So 5 times 1 over 8 to power 2 is 1 over 64. So now we simplify further, we can add this, right? So 256 plus 8 plus 3, that's 267, and then we have this part here, this is 7 over 8, 7 over 8 plus 5 over 64. Okay, so we have 267 plus, well, the LCM here is 64, right? The LCM is 64. 64 divided by 8 is 2. This is 8, sorry, 8. 8 times 7. 8 times 7, that's 56 plus 64 divided by 64, 1 times 5 is 5. So basically, what we have now is 267 plus this is 61 over 64. 61 over 64. And if we use a calculator, we'll get 267 point 0.953125 in base 10. So we've converted that one to base 10. So moving on to the next example, example 5, where we'll be dealing with base 16. We're asked to convert BD6, right? BD6 in base 16 to a number in base 10. This isn't new to us, so okay, what the only thing that might be new is BD. So this is how we're going to tackle this problem. This is how we're going to tackle it. We know that B and D represent 11 and okay, let's list them: A, B, C, D, E, and F, right? So A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. So this is very important. We are going to use this when we are. So what do we do first? We number 1, 0, 1, and 2 from the left to the right, and then we simplify. So we have B. B is 11, right? So it's 11. It's 11. We have 11 times 16 to power 2. 16 is the base plus D times 16, right? But B is 13. B is 13, so it's 13 times 16 to power 1 plus we also have, this is 6, so there is no need for it's not, it's 6, 6 is 6, right? So 6 times 16 to power 0. So we're ready to solve 11 times 16 to power 2. Times 16 to power 2 is, first of all, 16 to power 2 is 256 plus 13 times 16. 16 to power 1 is 16, then we have plus 6 times, this is 1. 16 to power 0 is 1, so that's done. So we can just simplify everything there. So once we do that, we have the final answer of 3,030 in base 10. 3,030 in base 10. Once we do 11 times everything here on the calculator, we get 330. So that 330 is the base 10. Now finally, in this video, we'll be solving this example. In example 6, convert A87, so A87.EF in base 16 to a number in base 10. So this one has decimal points now. How do we do it? We have been doing it, and so it's just still the same process. We've been doing that ever since this video began. So it's not really that new to us. So as usual, you want to get your letters and what they represent. So A represents 10, B 11, 12, 13, 14, 15. So we now have what each letter represents, which would now help us in simplifying this, converting this to base 10. So as usual, the number before the decimal point, in this case 7, takes on 0. So 7 is taking on 0, 8 is taking on 1, 8 is taking 2, E will take -1, F will take -2. If there was another number or letter after F, it will take -3, and so on, -4, -5, -6. Even here, 3, 4, 5, 6, 7, 8, and so on. So simplifying this, we have A is 10. We know that A is 10. So this is 10 times the base 16 to power 2 plus we have the next digit 8 times 16 to power 1 plus 7 times 16 to power 0 plus E. We come across E, we check and see that E is 14. So 14 times 16 to power -1 plus, we have an F here. So F is 15. 15 times 16 to power -2. So we have to evaluate this. This is 10 times 16 to power 2 is 256 plus 8 times 16 to the power 1 is 16 plus, as usual, we've got to note that any number to the power of 0 is 1. So we have 7 times 1 there. Okay, so plus 14 times, as usual, when we come across a negative power, we say 1/16 to that power without the negative sign. Without this negative sign, that's 1. And plus 15, the same thing again, but this time around is 2. 16 to power -2 is 1/16 to power 2. So further simplification gives us so we have 10 times 256, that's 2,560. Then we have 8 times 16, so 8 times 16 is 128 plus 7 times 1 is 7. Then we come across this. This gives us 14/16, right? 14/16, because 1/16 to power 1 is 16. And finally, 15 times 1/16 to power 2, that's 15 divided by 256. Yeah, 15 divided by 256. The 15 just comes on top and then 16 to power 2 below. So you can just use a calculator to evaluate everything here, and then you'll get 2,695.933594 in base 10. So that's the answer. Okay, so that brings us to the end of this lesson, lesson 1 on DLD. This is the DLD series, and we'll be covering a lot of topics in DLD. Don't forget to like, share, and subscribe if you have enjoyed what you've seen, if you have understood what you've learned. Like, share the link, and don't forget to use the comment section down below. Place comments, ask questions where you don't understand, and I'll be answering them on Fridays and Saturdays. That brings us to the end of this video, and have a nice day.